In this video lesson, we are going to talk about our fourth mechanism that can cause evolution. And that fourth mechanism is non-random mating. So fourth mechanism, I want to think about your fourth finger on your hand away from your thumb. That fourth finger away from your hand, that's the finger that we put rings on when we are going to marry someone. And usually when we marry someone, we are going to be choosing to marry that person for certain reasons. Our mate choice is not random. We chose that person. So the fourth finger is going to be for non-random mating. We chose our partners. So in non-random mating, it says that the probability that two individuals in a population will mate is not the same for all possible pairs of individuals, because some individuals are going to choose to mate with others based off the characteristics that they have. Think about if you were going into a bar. If you had random mating, your mate would be the first person that you came across. That would be your mate. So non-random mating, that usually doesn't happen, or it usually happens because we usually are going to choose our mate based off of some characteristics that they have. Now, assortative mating is a preference to mate with partners who are phenotypically similar to themselves. So they have a phenotype or an appearance that is similar to theirs. So for example, if we have a blonde-haired person, they might prefer to date and mate with another blonde-haired person. Their phenotypes are similar. Now, usually in this type of mating, it's going to result in excessive homozygous genotypes in the population. And the reason why we're having excess homozygous genotypes is because if you are preferring to mate with someone with a phenotype that is similar to yours, that's going to result in more of those homozygous genotypes where you have two copies of the same allele coded for in your genotype. Now, when you have assortative mating, it is very similar to inbreeding. Inbreeding is when you have two organisms that are closely related that mate with each other. And just like inbreeding can lead to an excess of homozygous genotypes, so can assortative mating. So those two are very similar. Now, one more thing to talk about non-random mating is that the size of a population can affect non-random mating. So if your population is very large, it's going to probably be spread out over a very big distance. Organisms that live closer by each other are probably going to mate with each other more often than if they're spread out. So if the population is very large, there would not be equal access to all possible partners. So the size of the population can affect non-random mating. So look at this example here with our beetles. We have on the left side, we have a beetle that is doing random mating because it might mate with the beetle on top with that tan color. It's not phenotypically similar to it. It could possibly mate with that one that is similar to it, and it could possibly mate with that one that has the yellow back. So that would be random mating. Whatever one it came across first, that would probably be its mate, and it would mate with it. Whereas over here, we have an example of non-random mating, and it would be that assortative mating, because this beetle is choosing to mate with that beetle because it's phenotypically similar. So it's choosing its mate based off of the characteristics it has. So that would be non-random mating. And non-random mating is going to affect evolution because if you are choosing your mates, there's going to be some organisms that are more reproductively successful than others. And reproducing, that's a part of the evolution we've been talking about. If you survive and reproduce more, you're going to pass on your genes more and you're going to affect future generations. So non-random mating affects reproductive success, which leads to changes in the gene pool over time. So now an example problem. This problem says, which of the following is an example of random mating? So we're looking for the mating being random in this problem, not non-random mating. So the first example says, A, the largest and strongest males mate with the most females. That's not random. They're choosing. The females are choosing to mate with the largest and strongest males. Because they're choosing, that means it's non-random, and we are looking for random mating. Answer choice B says, a female bird will only mate with males that perform the best courtship displays. Once again, that is not random. That is the female choosing who she wants to mate with based off of a certain phenotype. This time it's a behavioral phenotype where we have a courtship display. So because the female is choosing, that's not random mating either. And looking at answer choice D now, it says female birds of paradise select the most colorful males as mates. Once again, the female is choosing. That is not random. That is going to not be our answer since we're looking for random mating. So finally, answer choice C must be our correct one, but let's double check to make sure. It says that some males mate with any females that they encounter. That sounds like random mating to me. The first organism that you come across is who you mate with. That is random mating.